MeshLib is a SDK for advanced 3D mesh operations using Python and C++. There are many features such as remeshing, subdividing, filling holes, decimating, and much more. In this video, I will be talking about the MeshLib SDK, 3D Boolean operations, decimation, offset, and by the end of this video, we will see how we could take this model of the teeth and create a mouth guard up on top. For more information on robotics and AI, check out my website at kevinwoodrobotics.com. If you're new to my channel, I teach robotics and AI, so subscribe to learn more. So I want to walk you through what we will be doing in this video today. So here you see we have the model of the teeth, and then we also have the model of the night guard mold. So the idea is we want this mold to fit for this set of teeth. So how do we do this? The idea is to apply a Boolean operation to remove material from the night guard so that it can fit properly. So after that, we may want to do some post-processing. So let's say we want to simplify this model. We may want to run the decimate function, and this will give us a simplified model. And then from there, we could work with it, do different things. So for example, maybe it doesn't quite fit in the model, and we want to remove some of the material. We could apply an offset, and this will give us a modified model. So before I dive into the MeshLib SDK, I want to share with you the MeshInspector. So this is a standalone application that is built off of MeshLib SDK. So it's a great way for you to actually view your models and do operations if you choose to do it through a GUI interface. But with MeshLib SDK, you get full control over everything, and you could create your own applications as you wish. Okay, so here is the MeshInspector, which is a user interface available on their website. So there's a desktop version you could use, or you could use the web version, which is the one I'm using. But to use this software is very easy. So here you can see it says to drag and drop files anywhere to open. So if you want to start viewing your meshes in here, it's very easy. You could just drag and drop. So here, I have a folder of the two models that I will be working with today. So if I select the two and then drag it here, you can see that it automatically imports my mesh. So if you've used any 3D editors before, it's the same way. So if you, with your mouse key, if you click on the wheel, you could rotate it, right, like I'm doing here. And then if you right-click it, you could pan the model. And then the left click is just to select different things. So first off, you could look at the top. You have these different tabs here. We have our home, where you could open your files, open different things. You have your settings and all that. You have your view tab, which lets you have different views of your model here, as you can see. And then you have your select tab. The select tab lets you select different things, clear selections, delete selections, and so on. The create tab lets you do different things like here's a clone and merge and so on. Up here is a transform tab, so you could apply different transformations. Inspection to figure out any issues with your model. Here's another features tab here, mesh, points, you have voxels, and CNC, right? So there's a bunch of these applications that you could dig into for what you need. So I'll just briefly show you how to use this because we'll be using this to view our mesh results later on. So I just want to show you really quick how to use this. But right here is the most important part that I'm going to be using is here on the left panel. You can see that I can click the different things I'm viewing, and then within each model I could right click it, and then I could choose the color that I want to view it in, right? So here I made it green, and then I hit this part. If I select both parts, you can see that's here you can see that both of them are selected. But right now, notice that it's a smooth model, like a 3D model, right? So if you want to see more details, what you could do is right click it. And then here you could click on edges. So this edges will allow you to see the actual meshes one at a time. And this is very useful later on when we're going to do things like decimation. You're going to actually see the different meshes change. And it's just a really nice feature to actually get down to the fine details of your model. Okay. So here, let's see the other things that's nice too is you could play with the transparency. Let's say you want to see what's behind another part. That's also pretty useful. But I would say these are the main features that you need to know how to use for this tutorial I'm going over today. And then if you want check out more advanced features, just go ahead and go to the Mesh Inspector and check it out for yourself. Okay, so now we're going to take a look at MeshLib. So this is their main documentation website for their SDK. So this is a great place to start if you're trying to do any sort of Python or C++ applications with their MeshLib SDK. But you can see here on the left, you have the overview, coding style, and the different things like Python overview, examples, topics. So we'll be going over some of these today. But here in the overview tab, you can see that this gives you instructions on how to build and set up for your Windows here. So this is a great place to start. Teaches you step by step from cloning and what folders to go to and what installation files to run. You also have steps for CMake on Linux if you're a Linux kind of person. So there's a lot of clear instructions on that. This part is for the Python integration. So in our tutorial today, we'll be going over the Python one. So this part might be the one that you want to pay attention to, but it's pretty simple. It's just going to be like pip install your MeshLib here. You could upgrade it if you need to upgrade, but you just need to run these few commands and you should be up and ready to go. So here you can take a look at this Python overview. So you can see here that the Python version that it's been tested with is between 3.8 and 3.12. So make sure you have that. And then once you have everything installed, you should be up and ready to go. Okay, so here in the examples tab, first you could, if you're using C++, you could like look into these. The Python examples is the ones we'll be going over. So you could see that there's a bunch of examples you could take a look at. You have the loading and saving, NumPy support, mesh modifications, simple triangulation. Here's a decimation, Boolean, offset, but we'll be actually running some of these live to see what's going to happen, right? And here you can see that there's also a bunch of topics. So this here, the way the C++ and Python works is that there's going to be a binding between the two. So Python is acting as like a wrapper that's calling the C++ library in the backend. So you can actually click through all of these to get more details on how each of these topics works. So this is a great place for you to look into more of the documentation if you want to see more details on how to actually call some of the functions or what each of the variables is doing. This is a great place to look at. And if you need to find something too, it's a good idea to use this search menu on top too. So like, for example, if I type in like decimate, you see that these are all the different things related to decimation. So this is a good place to search for things that you can't find if you're not too familiar with the layout of this documentation. So we'll be jumping in shortly into some live demos, and you could see how some of this stuff work later on. Okay, so let's take a look at some of the most popular open source mesh Boolean libraries. So you can see here up on top, you can see that there's several types here. We have MeshLib, mcut, manifold, and all these other ones, right? So here you can see that some of the main differences that this table compares is the licensing option. So depending on what application that you need or the different considerations, you could take a look at that to see if it meets your needs. So if we take a look at some of the comparisons, so here is some of the statue that people like to compare with here, and you can see that there's different cases here that we're looking at. So we have here first up top is the union, and then we have the intersection, and then we have the difference. So if we look at some of the results here, notice that to actually read this, one thing to know is that all of the results are in seconds here. So we're comparing all of the different libraries that we saw earlier. And if you take a look at the first one, which is the union, you can see that MeshLib is significantly faster than the other ones. You can see it's standing here at 1.2 seconds versus you can see that some of it goes as high as even 40 seconds. So it's a pretty drastic difference, right? And then if you look at the intersection, you can see that here again, it's only at 0.7, so it's very fast compared to the other ones. You can see the closest one is like 1 second with the manifold one, but overall you can see that MeshLib is definitely way faster. Same thing with the difference. You can see here we're at 0.9 versus the other ones, somewhere between here like 40s, 6 point something, 41s. So you can see that this one is way faster than all the other ones. So if you're looking for speed, MeshLib is the one to go, right? And we look down here, this is another one with a dental case. Again, there's some examples here of union, intersection, and difference. So again, here you can see some of the results of MeshLib compared to the other libraries in terms of speed. So here you can see MeshLib, a lot of the speeds is around 0.18, 0.17, and 0.2, whereas its competitors, you can see that some of the numbers are anywhere between like 0.7 all the way up to like 5. So, and even for MCUT, some of it tends to fail some of the tests. So you can see that if you're looking for speed, again, it outperforms a lot of these other competitors. Now, before we go into the Boolean coding example, you might want to take a look at some of the documentation that they have here. So you can see here what it says is a surface Boolean overview. So this is the overview of all the different things. I would say the most important part that you want to pay attention to, at least for our demo today, is this part, which is the enumeration. So we have all these different cases that we'll be testing out. And then if I scroll down, there's going to be some documentation that goes into the different types that we'll see. Okay, so the first thing that we're going to run in our Python program here is the program called run Boolean cases. So we jump into run Boolean cases. What you see here is I have a list of operations. So the difference, inside, intersection, outside, and union. And I'm going to put it inside a for loop, pass it in to my run Boolean function, and my run Boolean function here is going to print out each of the cases I'm running. I'm going to have two meshes. One is my bottom of my teeth, and then the other one is the mold. And it's really simple to use. You just need to call the mesh Boolean function here, and you're going to pass in the bottom and mold and the method, and you're going to extract the results using result.mesh. And if there's some error, I want to print it out. And after that, I'm going to save each of the files. So really straightforward. And you just have these includes up here. Some of it that I have for plotting I'm not using right now, but the main ones are the ones up here. So I'm going to go ahead and run this, and you're going to see how fast the Boolean operation takes to finish. So this is great if you have thousands of files you're running, but just look at that. Everything is running under 0.1 seconds. So you see like 0.05, 0.06, 0.03, very, very fast. You can see all my files here have been generated here. So let's go ahead and jump into MeshInspector and take a look at these files. Okay, so you can see here we're in our MeshInspector, so we could take a look at our results. But you can see that these two are the first original meshes that we're working with. And we'll go down one by one the results of the Boolean operations. So I'm going to go ahead and hide this for now, but the first one here is the Boolean union. So the Boolean union, as you can see, this is result of combining the two, and that's what we expected. The next one we're going to take a look at is difference AB. So you can see now we have the bottom half, which is also what we expect. Difference BA, this one is the one that actually forms the mold. It could be like a night guard, for example. This is the results of that. And if I go into the next one, this is called inside A. So you can see that this ends up forming a shell of the teeth. And this could be nice if you're trying to make like maybe like a set of fake teeth or some sort of retainer, like a kind of like Invisalign, right? This kind of looks a little bit like that. And here we have what's called the inside B. This is not really practical in this case, but you can see the results of the inside B here. And then here we have the intersection. So this actually gets the solid part of the teeth instead of a hollow version. So this might be cool if you're trying to extract the teeth only. And then here we have the outside of A. So here you can see this. You can see this part is hollow here because it's the outside part. And then finally we have outside of B. So again, it's like the shell of the mold. All right, so now let's go ahead and dive into decimation. So MeshLib here has some case study between VTK and MeshLib, but the idea of decimation is you want to reduce the number of meshes while preserving some of the same critical features of your model. So here you can see this is the original. You see there's a bunch of triangles here, a total of 1 million triangles. And then VTK, it took about 11 seconds. And even though it took 11 seconds, you can see that some of the results resulted in some holes in the meshing here. And then on the far right, you can see MeshLib here. MeshLib took about 4 seconds with sequential algorithm or 1 second with parallel algorithm. And you can see that a lot of the final finish of MeshLib is pretty good. And then here you can see more about the decimation quality. You can see that with VTK, there's some degenerate triangles here, whereas MeshLib gives a very uniform mesh, as you can see on the right. So based on some of these case studies, you can see that MeshLib has much better quality. So if you're looking for a nice uniform mesh, this might be a good one to try out. So here you could take a look at some of the decimate function overview, some of the information on their classes. So you could take a look at that. All of the details is here on how to use it, the input variables and everything. And up on top, you notice that right here you have the decimate settings. So this part tells you about the max error. That's the main thing that we'll be playing with. And then there's some other variables you could play around with if you really need to get down to the specifics of exactly how you want to decimate your model here. So go ahead and take a look at that and see which one you need. But our main focus will be with the max error today. So you can see here in our main function, we have the run decimate cases. And you can see inside of here, we're going to be testing out 4 different errors, 2, 1, 0.5, and 0.25. And I just put it in a for loop, going to run over all the error cases and take a look at our run decimate function here. We're going to be printing out each cases, and then we're going to be using the difference BA from our previous function that we ran. And we're going to call out the settings here, set our max error to the different max error cases that we looked at just then. Going to call the decimate mesh function. This will end up modifying our mesh and then outputting the modified mesh. And then we're going to save the meshes with the respective type of error that we're testing out. So if I go ahead and run this, you're going to see this running in real time. Just a couple of seconds to finish, very fast. And you can see that these are our outputs here. We're going to go ahead and view this in our mesh inspector now. Okay, so now we are here in MeshInspector. This one is our original mesh called the Boolean difference BA, but you can see this one here has about 30,000 faces. And let's see how it changes by changing the max error. So here, if I scroll down, you can see that this one right here is our decimate 0.25. So this one brought it down to about 6,000 faces. And you can still see a lot of the structure is preserved. And if I go even lower, you can see this one right here is the 0.5 error. We're down to about 3,000 something faces. And again, you can see the structure is still preserved pretty well. Very impressed. And then right here, we are down to like 2,000 something faces. This one is at error of 1. And then if I go even higher error tolerance, you can see this one right here. We are at about 1,000 something faces. And you can see overall, the structure is still pretty good. Very impressed. Okay, so now for our last example, we're going to be doing the offset, which is going to expand the model here in some uniform direction. But here you can see that this is the offset mesh function. You go ahead and read more about it here. And you can see we also have the offset parameters. This is some of the settings that you could set. One of the main ones that we will be looking at right here is going to be the voxel size here. And then you have the sign detection mode. So those are the 2 main things. So you could take a look at that for more information. So now we're back in VS Code. We're going to go ahead and run our last case here, which is run offset cases. So if we go ahead and jump into run offset cases, you can see here we have our 3 cases. We're going to put it inside a for loop and then run our run offset function. Inside our run offset function, we're going to be printing out each of the cases as we run it. We're going to be passing in our Boolean difference BA STL file. And then we're going to pull out the parameters, set up the voxel size, and then we're going to find the right boundary here to see if it's empty and take some action. And then here we have our offset. It's going to be based on our offset scale, which is we're passing in, and we're going to multiply that with the diagonal. And then here we're going to apply the offset mesh. So this is the main function that you need. This will give us our resultant mesh. And then we're just going to go ahead and save it after we run it. So if I go ahead and run this, you can see it running in real time here. And then after the three things are done running, you can see that our files are right here on the right. So like before, we're going to go ahead and jump into MeshInspector to take a look at these files. So here you can see we are back in MeshInspector, and this right here is our original difference BA model. But you can see here, if I first click the smallest one, the smallest offset that we did, you can see that this is the offset here. And if I go ahead and go to the next one up, the 0.5, you can see it gets even a little bit bigger. And then the very last case is the 0.01, and you can see how much more this one covers. So you can see that it's working as expected. In practice, you wouldn't use the offset for this specific application. Maybe the smaller one, like the 0.001 might be more applicable. Maybe let's say you made a mold and it's a little bit too loose, then you might need to add a slight shell over it. Then this might be the right use case for that. But I chose some bigger offsets to kind of exaggerate it so you could see a little bit better what's happening. Okay. So if you found this video helpful, give a like and subscribe, and I'll see you in the next one.